So we now have a good understanding of what turnout feedbacks are and how to use them. So next we can move on with inserting a single feedback sensor on our switchboard and checking the physical wiring. Okay, so we're going to use the single feedback method, which means we will insert a feedback element on the turnout structure in the switchboard. Now you don't have to show the feedback in the turnout structure. You can just create it and define it in the feedback editor and assign it to all of the turnouts in the structure, and the feedback sensor would not be displayed, but the turnouts will still show the occupancy by changing their colour. But we will insert one. So we go to the switchboard. Now I like to have the feedback tab showing so I can see which addresses and names have been used. We need to insert a feedback, so click where you want to insert it, and this piece of track is grouped to that turnout shown by the lilac or blue colour. We will delete that, or if you don't have a piece of track here, just create a space for it. Select the feedback, rotate it with T or R, and then press the space bar to place it. We will now follow the same 5-step procedure similar to the way we installed the signal. So step 1 is to define it. Double click to open the properties, then give it a short unique name. I will call it feedback turnout, and the next address is number 6, so 06. You can give it a full description if you prefer, and then in the type field, as we saw in video 15.5, the only types we should use for a turnout feedback are the occupancy or the button. I will use the occupancy, and we leave the length at 0 centimeters because length is not used in a turnout feedback. This is going to be a real device and not a virtual device like when we installed the signal, so we do need to assign an interface and give it an address. It will be number 6 in this case, and then press OK. So we have defined the feedback, but we also need to assign the feedback in each of the turnout properties. So we double click, go to the options tab, and then select the feedback we just created, click OK, and then do the same thing for each of the other turnouts. Feedback 06, and the last one, feedback 06, and click OK. So let's apply and save to save everything that we've just done. So we've now assigned each of the turnouts to that single feedback, and we also need to do the same with the physical wiring on the layout. Here's a simplified wiring diagram for the single feedback method using a current sensing feedback module. Just like we assigned all the turnouts to a single feedback in iTrain, we do a similar thing with the wiring. So here we have a wire going to each of the turnouts in the structure, and all the wires are joined together and attach to a single sensor input on the feedback module. The symbols here in green represent the insulated rail joiners required for this setup. Now, often insulated rail joiners are not required on the common rail, but consult the manufacturer's documentation for your setup. And for reference, this is the way that feedbacks per turnout would be wired. So each wire from the various turnouts goes to a separate sensor input on the feedback module. Now, the exact details of how you would wire your feedbacks to your hardware may differ, so consult the manufacturer's documentation. This is only a general simplified wiring diagram, but essentially the operation would be like this. There is a command station that produces the track power. The current flows out the red wire to the turnout structure, flows to the other rail through the loco's motor when the train enters the turnout, flows along the yellow wire and into a single sensor input on the feedback module where the current is sensed, then flows out of the feedback module and returns to the other track power input connection on the command station to complete the circuit. The current sensed in the feedback module is reported back to iTrain, usually via a network cable, to the command station and then onto the computer and into the iTrain software, where the occupancy is displayed on the switchboard. Okay, so that is step 1 completed. We've inserted the feedback, defined it, assigned it to each of the turnouts, and seen how we physically make the wire connections to the structure for the single feedback method and for the per turnout method. In the next tutorial we move on to step 2, which is grouping the feedback, but not to the block in this case. So until then, bye for now.